So this is the model I made for the resource for the conic section. So I decided to use the parabola from the questions given. So it's just quite a simple resource. So I have the cone over here, and then just the rest of the model. So I found it the same way as the question. So I have the cone, then you have the cutting plane here. So I then had to find the sphere, the focal sphere on the inside, and I just got that quite simply on SolidWorks. So then I just had to find the focal point, the vertex, and the directrix. So the focal point is just where the sphere comes in contact with the cutting plane. The vertex is then where the cutting plane and the side of the cone meet. And then for the directrix, to find that, you have to get the horizontal line through the two tangents of the cone and the circle or the sphere, and where that line and the cutting plane meet, that's the point for the directrix. So you bring all these points out perpendicular to the cutting plane then, and you can set up the rest of it over here. So just like that. So we have the directrix, the axis here, the focal point, and the vertex. So it's quite a simple model. So you can see as I move the cutting plane in and out, you can see that the parabola starts to move. So the bigger the focal sphere inside here is, means the shorter the distance the cutting plane is cutting, and that then it gives you this shape for the parabola. And then vice versa, if I move the cutting plane so it takes out a bigger section, the focal sphere gets smaller, and then the parabola starts to elongate to make a bigger surface. So the reason I have this line in here as well then is just so that the parabola will always stop at the bottom of the cone, just so that it actually gives us the true shape of what's being cut out.